Welcome to the fascinating journey of glycolysis, the metabolic pathway that powers life. Glycolysis takes place in the cytoplasm of the cell and is the first step in breaking down glucose to release energy. Let's dive in and see how one molecule of glucose becomes two molecules of pyruvate. It all starts with a single molecule of glucose, a 6-carbon sugar. Glycolysis unfolds in 10 steps divided into two phases, the energy investment phase and the energy payoff phase. In the first step, an enzyme called hexokinase phosphorylates glucose, using one molecule of ATP. This forms glucose 6-phosphate and prevents glucose from leaving the cell. Next, glucose 6-phosphate is converted into fructose 6-phosphate by an enzyme called phosphoglucose isomerase. Here comes the key regulatory step. Phosphofructokinase 1, PFK1, adds another phosphate group to form fructose 1,6-bisphosphate. This step uses one more ATP. The sugar is now split into two 3-carbon molecules, glyceraldehyde 3-phosphate, G3P, and dihydroxyacetone phosphate, DHAP. Only G3P continues directly in glycolysis, but DHAP is quickly converted to G3P. Now the energy payoff begins. G3P dehydrogenase oxidizes G3P, adding a phosphate group to form 1,3-bisphosphoglycerate. This step generates NADH, an important electron carrier. The enzyme phosphoglycerate kinase removes a phosphate group, converting ADP to ATP. This produces 3-phosphoglycerate and marks the first ATP gain. Phosphoglycerate mutase shifts the phosphate group, forming 2-phosphoglycerate. The enzyme enolase removes water, creating phosphenolpyruvate, or PEP, a high-energy molecule. In the last step, pyruvate kinase transfers the phosphate group from PEP to ADP, forming ATP and pyruvate. And there you have it. Glycolysis transforms one glucose molecule into two pyruvate molecules, two net ATP molecules, 4 ATP produced minus 2 used, and 2 NADH molecules. This is the gateway to cellular respiration, where even more energy can be harvested. Stay tuned for the Krebs cycle and oxidative phosphorylation. Thank you for exploring glycolysis with us. Remember, every breath you take fuels this process. See you next time.